We'll walk you through some basic word problems using systems of equations. So the challenge in these problems is not in solving the system. The challenge is to take the word problem and set the system up, and then the solving part should be the easy part. So we'll start with something like number 1. The sum of two numbers is 30 and their difference is 12. Find the two numbers. So the object is to use two variables, not to try to figure this out as a brain teaser, but to use two variables for solving. So now I can use both x and y. So let x be one number, and then y is the other number. The sum of two numbers is, so that's just simply x plus y, is equates with the equal sign. The sum of two numbers is 30. Their difference implies subtraction, their difference is 12. And it doesn't matter if you set up x minus y, y minus x. It doesn't matter, it works out both ways. I just keep it really simple and go with x plus y, x minus y. This now becomes my system for solving, and I can see that this is set up very easily for elimination because positive and negative y will sum to 0. So I have 2x equaling 42, x is 21, and then go back to either original equation. If x is 21, then that implies that y is 9. So the two numbers would be 21 and 9. Let's look at a different problem from this set. I'll just move on and look at number 3. The difference between two numbers is 9. So I'm just going to simply write x minus y is 9. Difference implies subtraction, is equates with the equal sign. The first number plus twice the other number. So I'm just going to say that x is my first number plus twice the other number. The first number plus twice the other number is 27. So this now becomes my system for solving. You can use elimination, you can use substitution, you can solve as you wish. But the object of this video is to help you set these systems up, not to show you how to solve the systems. So let's look at one more in this problem set, and then we'll move on to a different problem type. In fact, I think all of these are the same, so I'm going to move on to the next problem type. And here, I'm going to set these up in standard form. And each word problem lends itself, or could possibly lend itself, to a different equation type setup. So here I've got 3 boxes of envelopes, 4 boxes of notebooks. So I've got envelopes and notebooks. And if I let x be the envelope, I'll let y be the notebook. I have 3 boxes of envelopes, so that's 3x, and implies addition, 4 boxes of notebooks, and the cost is $13.25. So that is the first sentence translated to algebra. 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. So that's my first equation in the system. And then my second equation, I have 2 boxes of envelopes, so that's 2x, and 6 boxes of notebook paper, so that's 2x plus 6y, and the cost is 17. So this becomes my system for solving. You solve as you wish. It doesn't matter at this point. I think I would use elimination with this system because none of the coefficients are matching, so I think this is a good candidate for elimination. But the object of this video is not to solve the system. The object of this video is to help you set the system up. So let's look at another one. And I'll go down and catch number 9. So here, let's see, pens and pencils. Those are my 2 objects, pens and pencils. And I'll just let the x be the pen. It is important for you to identify what each variable stands for. Y would be the pencil. Okay, so the first person purchased 4 pens and 5 pencils. That's the direct translation of that. And the amount of money spent, $6.71. Then the other person purchased 5 pens and 3 pencils. So that's the algebraic translation for that. and the cost was, and I've written on top of my number, 712, setting that equal to 7.12. This now becomes my system for solving. I would use elimination with this system. I would not try to use substitution with this. Let's see, let's look at number 11 since it's on the screen. Let's see, I have a garden supply store selling two types of lawnmowers. So I've got small and large. So this is going to be number 11. So if I say X is small, then Y is large. So read the problem to determine which two objects you're talking about. So the smaller mower, I'm given the cost of the larger mower, and let's see if 30 total mowers were sold. Okay, so this one's slightly different. So this is the quantity value problem. So how many have I purchased, and what is the value? Okay, so here I've purchased a total of 30. That's combining both the small and the large. So my first equation looks like X plus Y equaling 30. And then my next equation is going to describe how much money I spent. So the number that would go in front of the X is now going to be the cost of the smaller lawnmower. So I would have this number. That goes with my X. And then I'm going to have the number that describes the cost of the larger lawnmower. That goes with my Y. And then I set that equal to the total amount of money that I spent. And then that becomes the system that I solve. And the 0 ran off the screen, but you have access to the right numbers here. So this is slightly different from the examples above, because in this particular system, you're told how many of something you've purchased, or a quantity, and then in the next equation, you're describing the value of what is the quantity that was described in the first equation now has value attached to it in the second equation. And I think that this actually looks like a nice system for substitution, because I have X plus Y, both of these with the coefficient of 1. So I would solve this equation for either X or Y and make a substitution into the second equation for either variable of your choice. Let's do a few more of the quantity value problems. So we'll stay with that theme. Quantity is one equation, value is the second equation. So a problem like number 12, let's see, I've got baseballs and I have bats. So if I let X represent the baseball, and then Y would represent the bat. So the first equation is going to describe how many of each I have, my quantity equation. X plus Y equaling 100. And then my second equation is going to attach value, cost. How much money did I spend? So my first would be 4.5, $4.50 for baseballs, and $20 for one bat. So that's the algebraic interpretation of that. And then the total amount of money that I spent, $822. And once again, I think this is a good candidate for the substitution method. But you can do as you wish, but it would be a nice candidate for substitution because it's easy to isolate X or Y in the first equation. Let's look at the next problem together. Let's look at number 13. And here I have 40 children, and each child has received either a hot dog or a bag of popcorn. So I'm going to let the X represent the hot dog, Y represents the popcorn. So quantity, how many children, how many things, how many hot dogs and bags of popcorn did I purchase? That's going to be 40. So X plus Y equals 40. And then I attach value to each. So the hot dog is $2.25, so that's 2.25x. And then the bag of popcorn is $1.75. So I attach value to Y, and then the total amount of money that I spent, $83.50. And I'll do one more on the video, just the setup, and then once again, for this particular system in number 13, you can solve as you wish, but I do think that substitution using this equation would be extremely simple to do. Just solve it, isolate either X or Y, and then make a substitution into the second equation in either the X or the Y spot, and that allows you to solve for both variables. And let's see, moving on to number 14. Here I've got movie tickets. I have adult and child. So X is the adult, Y is the child. I purchased 548 tickets, so X plus Y. And then the next problem attaches value. So 6.5X and 3.5Y. And I spent $2,881. And once again, I think it lends itself well to substitution, but you can solve as you wish.